Hello, welcome to Dakota Prep's video tutorial for sizing a neutral conductor for a dwelling unit. Now, what we're going to focus on here is going to be section 220.61. Now, I do want to warn you guys, there are a ridiculous amount. Let me write that better. That's really bothering me. Like I said 220.61. Now there are a ton of rules involved in this, and then all for nothing really. But you know what? This is the type of question that you may see on your state test. Now, I want to remind you guys, I know I talked about this whenever we did your load calc. Hey, NXD is our friend here. NXD has examples for how to do these types of things. You just plug your numbers in to the NXD example. No big deal, right? We don't have to memorize all this stuff. First thing we need to do is read our question. It says, what is the minimum allowable ampacity for the service neutral for a dwelling unit that has a floor area of 1,500 square feet, an 8 kW range, and 4,500 watt dryer? Okay, tricky. There's a tricky little rule in here dealing with that dryer. So first things first, let's go ahead and find our general lighting load, right? Our general lighting load. So our general lighting load is, I'm jumping the gun. Do you see what I just did there? I went ahead and multiplied it. So we got 1,500 square foot dwelling unit times 3 volt amps per square foot gives us 4,500 volt amps, right? Now we look at table, those are volt amps. Now we look at table for, I'm sorry, not for 2, let's not jump the gun here, 220.45. All right, that allows us to apply demand factors. It says, hey, your first 3,000, let's go ahead and pull those out. That's 100%. We're left with 1,500. We multiply that by 35% for the remainder, and we're left with 525 volt amps. Okay, but we remember this first 3,000 has to be added back in, right? That has to be applied at 100%. So far we've got, let me just write this over here, 3525 volt amps for our general lighting. Okay, well, we've got two other things that they mentioned. It says, hey, you got an 8 kW range and a 45 watt dryer. So we go look at table 220.55 for our range. It says, hey, you can always use column C. Well, column C says, yeah, 8 sounds good. We'll just stick with 8. So it doesn't let us derate at all. We're going to have to go with all 8,000 here, volt amps. And then we have to add in 4,500 watts for our dryer. Okay, oh my goodness, 4,500 watts for our dryer. Now, the problem here, right, let's just erase that. Our problem is, if we go look at 220.52, no, I'm sorry, that is incorrect. 220.54, it says, hey, you know what, 4,500 watts for our dryer, not gonna get it done, because it has to be at least 5 kW for your dryer, right? Volt amps, whatever. Watts and volt amps are interchangeable in Article 220. Okay, now if we look back at 220.61, it gives us even another rule. It says, hey, these two guys here, this guy here and this guy here, right? You can apply a 70% demand factor to those. Well, yeah, of course, why wouldn't we? The unbalanced load for a dryer range is only going to be the electronics involved with that load. It's the only 120 volt loads on a range or a dryer. So maybe an old school dryer may have a timer or whatever, digital display, whatever. So 70% Still pretty conservative, in my opinion. We could go way higher than that, or way less, I guess would be the way to look at it. So what we got to do now? So we got our initial 3525. That's a we're gonna make that red. Okay. Okay. So this is the number we're going with, but we need to find 70% of 8,000 and 70% of 5,000 and add that all together. So 70% of 8,000 is 5,600. So let me go ahead and write that down here. It's 5,600. Now, 70% of 5,000 is 3,500. And then we throw our 3525 here for our general lighting load as well. And what we wind up with is a grand total of